China's all-new battery breakthrough shocks the entire industry. In this modern era, it is really difficult to find a gadget that does not use a battery. From small electric appliances, satellites, and modern electric cars, batteries are the most important. The most widely used batteries are lithium-based batteries. Automakers and battery manufacturers are looking for alternatives to lithium. Due to high material costs, price hikes, and supply disruptions, lithium batteries are now very expensive. As carbon neutrality has become a global issue, the new energy industry has entered a complex stage. The increasingly segmented markets have raised differentiated requirements for batteries. At the same time, the quest for basic materials for batteries has started off rapidly. In the world of EVs, lead-acid batteries were initially used. They were known for their heavy weight, slow charging, and discharging cycle. The industry shifted towards lithium-ion batteries, which were lightweighted and more efficient. Scientists started off developing sodium-ion batteries right alongside lithium-ion batteries. Over time, lithium rose to dominance and sodium fell by the wayside. But now, things have taken an interesting turn. Recently, CATL, a giant Chinese company, became the major battery manufacturer to unveil a sodium-ion battery. CATL, which also supplies batteries to automakers such as Tesla and Volkswagen, has surely changed the course of history with this major breakthrough. Contemporary Amperex Technology Company Limited, or CATL, is a global leader in new energy technology innovation, committed to providing premier solutions and services for new energy applications worldwide. The company is determined to achieve the goal of realizing fossil fuel replacement in stationary and mobile energy systems. The main focus of this giant company is to create highly efficient electrical power systems that are generated through advanced batteries and renewable energy. CATL maintains continuous innovation in 4 dimensions, including battery chemistry system, structure system, manufacturing system, and business models. CATL also unveiled an AB battery pack that integrates sodium and lithium-ion cells into one pack. This milestone will provide a new solution for the use of clean energy and transportation electrification. As electric vehicles become increasingly popular, demand for key battery ingredients, particularly cobalt, has spiked. This has spurred car and battery makers to seek alternatives to the current 3 main technologies: nickel-cobalt-aluminum, or NCA, nickel-cobalt-manganese, or NCM, and lithium iron phosphate, or LFP batteries. But the latest sodium-ion battery doesn't contain lithium, cobalt, or nickel. As the demand for EVs rise, the requirement for raw materials like lithium, copper, and nickel is expected to surge. Demand for lithium is also expected to rise drastically as it is a commonly used metal for batteries. According to the International Energy Agency, EVs and battery storage technologies are already accounting for 30% of the total current demand for the metal. This has accelerated worldwide research and development of basic materials for batteries. The major reason for CATL for this innovation is that China is heavily dependent on imports of lithium. 70% of China's demand for spodumene, a mineral that contains lithium, is imported from Australia. Furthermore, as the surge for lithium increases, the price of the metal is skyrocketing with each passing day. Lithium-ion batteries are so expensive that they determine the actual cost of any EV. So, by contrast, sodium is relatively abundant and cheap. The sodium-ion battery has a similar working principle to the lithium-ion battery. Sodium ions also shuttle between cathode and anode. However, when compared with lithium ions, sodium ions have a larger volume and higher requirements regarding structural stability. The Chinese government has prioritized and accelerated the development and commercialization of sodium-ion batteries. Hu Yusheng, a researcher at the Physics Institute at the Chinese Academy of Sciences, states, "As a new star of new energy, the sodium-ion battery is accelerating forward on the road of industrialization and may become an opportunity for China to lead a new round of energy revolution." So, why is sodium that important? Why is the shift from lithium to sodium-ion batteries such a major achievement? When compared to lithium, sodium is abundantly available. There is practically an infinite supply of this precious metal. The extraction and purification of sodium costs are lower, and its chemical characteristics are almost similar to lithium. This means that the mega industries producing lithium-ion batteries will not have to change the production machinery for sodium-ion batteries. CATL has stayed dedicated to the research of sodium-ion battery electrode materials for many years. The company has used Prussian white material with a higher specific capacity. It has also redesigned the bulk structure of the material by rearranging electrons. This has solved the worldwide problem of rapid capacity fading upon material cycling. CATL has developed a hard carbon material that contains a unique porous structure, which helps in abundant storage and fast movement of sodium ions. This has greatly enhanced the cycle performance of the batteries. CATL's thorough research has produced the first-generation sodium-ion batteries with great advantages. It has a fast charging capability and excellent thermal stability. The impressive low-temperature performance is a great advancement in the world of EVs. Even Tesla loses around 34% of its total range in low temperatures. This flaw can surely be rectified if sodium-ion batteries are used, as they are super efficient in cold weather conditions. According to CATL, the battery can reach 80% charging in just 15 minutes. When compared to the lithium-ion battery used in modern EVs, such as Tesla and Rimac, it takes about an average of 30 to 40 minutes to reach 80% charging at room temperature. This is a major setback faced by modern EV manufacturers because the car needs to be charged 2 or 3 times on a long-range drive. But if the EV is 80% charged in 15 minutes, this surely is manageable. The sodium-ion battery's thermal stability exceeds the national safety requirements for traction batteries. However, the sodium-ion battery currently has a lower energy density than a lithium-ion one. The sodium-ion battery cell can achieve up to 160 watt-hours per kilogram, whereas batteries used in modern EVs, such as Tesla, have a density of 272 to 296 watt-hours per kilogram. According to the chairman of CATL, Dr. Robin Sheng, the next generation of sodium-ion batteries will have an energy density of 200 watt-hours per kilogram. This will significantly enhance the range of EVs. CATL has made another breakthrough by integrating an AB battery system. It is an amalgam of sodium-ion and lithium-ion batteries in a certain proportion, integrating them into one battery system. This battery pack will be controlled through BMS precision algorithms. The AB battery system can compensate for the current energy density shortage of the sodium-ion battery. CATL has already kicked off the industrialization of sodium-ion batteries. As the sodium-ion batteries are compatible with lithium-ion batteries, the production equipment and processes are almost the same. Hence, there would be no need to make new factories with different engineering processes and equipment for large-scale production. As of now, CATL has started its industrial deployment of sodium-ion batteries and plans to form a basic industrial chain by 2023. As it is the latest innovation in the world of batteries, sodium will be a bit expensive at the start. It could take at least 2 years to see the economies of scale on the cost reduction. In the meantime, lithium-ion technology will still dominate the market. CATL has invited suppliers and customers, as well as research institutions, to accelerate and promote the development of sodium-ion batteries. CATL has always been committed to being a global premier innovative technology corporation. It has been delivering excellent contributions to the green energy resolution for mankind as its vision. To achieve its vision, CATL is making unremitting efforts in 3 strategic development directions. The first development direction is to replace stationary fossil energy with renewable energy generation and storage. The second is to replace mobile fossil energy by using EV batteries to accelerate the development of e-mobility. The third is to promote the integration of market applications with intelligent electrification and accelerate the drive towards new energy applications in different fields. Dr. Robin Zen, chairman of CATL, states, "Some people believe that the battery chemistry system will hardly see any more breakthroughs, and that only improvements can be made in the physical structure system. But we believe that the world of electrochemistry is like the energy cube, where there are still a lot of unknowns for us to discover. We never get tired of exploring its mysteries." There is no doubt that sodium-ion batteries offer superior environmental credentials. The cost of raw materials is far less than that of lithium-ion batteries. In addition, sodium-ion batteries also promise strong performance and continuous improvements in energy density and other factors. Still, in their infancy, sodium-ion batteries can be a great alternative to lithium-ion batteries. If the price of lithium continues to rise, then the lithium-ion cell could sooner become comparatively more attractive and secure a larger market share more quickly. Now, this is for the world to watch and wait if the lithium-ion batteries are used at their full potential. Let us know your thoughts on China's new battery breakthrough in the comments box below. And thank you for watching. This is Tech Revelations.